In this screencast, we are looking at application problems for systems of equations. So number one, LeBron James has made a total of 12 baskets. He has shot some 2-pointers and 3-pointers, and he has made a total of 29 points. How many of each type of basket did he make? So the first thing that we want to do is we want to read the problem and then maybe reread it as many times as we need to. And we're going to highlight some important pieces of information. So we know that he made a total of 12 baskets. He made some 2-pointers and 3-pointers, and he has made a total of 29 points. So the question we want to answer is how many of each type did he make? So how many 2-point shots, how many 3-point shots? So we need to define our variables first. We're going to let X be the 2-point shots, and let's let Y be the 3-point shots. So anytime we're talking about the 3-pointer or the 2-pointer, we're going to use X and Y. So going back into the problem, we are told that LeBron has made a total of 12 baskets. So again, we don't know how many of each type he made. That's what we want to find out. But we do know that he made a couple 2-pointers, some 3-pointers, to make a total of 12 baskets. So we have the equation X plus Y equals 12. So the second sentence says that he has shot 2-pointers and 3-pointers and has made a total of 29 points. So we can use the points with the X and the Y and write our other equations. So we know that he had 2-point shots that were 2 points apiece, so 2 times X, which is the number of 2-point shots he took, plus 3, because the 3-pointers are 3 points, times our Y value, which is our 3-point shots, equals our 29 total points. Okay, so we need to find out what is X and what is Y. So how many 2-point shots did he take? How many 3-point shots did he take? So we've learned a bunch of different ways to solve systems of equations. The way this is set up, we are going to solve it through elimination. So the way it is now, if we try to add these or subtract these equations together, nothing would cancel out or eliminate. So I'm going to multiply the top equation, the whole thing, by a -2. So my goal is to eliminate my x's. So 2x minus 2y is now equal to -24. The second equation stays the same, 2x plus 3y equals 29. And now we are going to add the two equations together. The x's will eliminate, which is what we wanted to happen. And then we can, combine like terms. So -2y plus 3y is y. -24 plus 29 is going to be +5. So we know that y equals 5. We can take this and plug it back into the y for one of our equations, which I'm going to use the first equation, so x plus y equals 12. So instead of y, I'm plugging in my 5. So now we want to add 5 to something to get 12. We can solve algebraically by subtracting 5 on both sides to get x equals 7. So we know that x is 7, we know y is 5, and we can go back and we can check them to make sure that it works in both equations. And when we go to write our answer, we want to write it in a sentence. So we can say that LeBron shot 7 2-point shots and 5 3-point shots. In example 2, we are given the problem, the length of Sally's garden is 4 meters greater than 3 times the width. The perimeter of her garden is 72 meters. What are the dimensions of Sally's garden? So first thing we want to do is we want to identify our x and our y. So we're talking about a garden. We have the perimeter. We are given the length and the width. So I'm going to make my x be length, and my y is going to be the width. So I'm going to go back in the problem and kind of highlight some key things. So the length of Sally's garden, so the length is 4 meters greater than 3 times the width. And then we know that the perimeter is 72 meters. And then we want to find out what are the dimensions of the garden. So I'm going to draw a picture because I'm a visual person. And we have the garden, and we're going to have the length is going to be the x. So I'm going to label that here. And our width is going to be our y. So going back into the problem, we were told in that very first sentence that the length, which is our x, is going to be 4 meters greater than 3 times the width. So we are going to take 3 times our y, 3 times the width, plus 4. So it's 4 meters bigger than 3 times the width. The second sentence says that the perimeter is 72 meters. And if you recall from your past education, that perimeter is all 4 sides added together. So we'll have 2x plus 2y, so both x sides, both y sides, are going to equal 72. So now we are going to use substitution to solve this problem. Since x equals 3y plus 4, we can take this 3y plus 4 and plug it in for x. That is the process of substituting. We're replacing something in for something else. So I'm going to rewrite my bottom equation, but now instead of x, I'm going to plug in a parenthesis, 3y plus 4, and then I have my plus 2y equals 72. So we are going to start by distributing the 2 inside the parentheses, so everything in the parentheses gets multiplied by 2. So we have 6y plus 8. We're going to bring down the plus 2y equals our 72. We are going to now combine like terms, so we can add the 6y and the 2y together to get 8y plus 8 equals 72. And then we can solve for y. Subtract 8 on both sides to get 8y equals 64, and divide both sides by 8. So y equals 8. Now, we're not done after this part. We know that y equals 8, but we still need to go back and find out what is x. So I'm going to plug it back into that first equation, x equals 3y plus 4, but instead of a y, we are going to substitute in our 8. So we can take 3 and 8 and multiply them to get 24 plus 4, and then that adds to give us 28. So if we go back to the problem, it said, what are the dimensions of Sally's garden? And remember, our x is our length. I'm just going to make a note here. And our y was our width. So when we go to write our answer, we can say that the garden is going to be 28 by 8 meters. Example 3, we have 30 coins, all dimes and nickels, are worth $2.60. We want to find out how many nickels there are. So we are going to start by defining our variables. So I'm going to say that my x is going to be my dimes, and that my y is going to be my nickels. So going back into the problem, we are told that there are 30 coins that are dimes and nickels. So we don't know how many of each type we have, so we can use that information to write an equation. So we know we have so many number of dimes plus so many number of nickels to give us 30 coins altogether. The second part of this problem says that it's worth $2.60. So we want to figure out, again, how many nickels are there. So we're going to use an equation. Now a dime is worth 10 cents, so we're going to make this 10 times x, because each dime is 10 cents, plus 0.05 for a nickel, because that's 5 cents, times our y value. And that's going to be equal to our $2.60. So we are now going to solve for x and for y. And we could do, substitution or elimination, and I'm going to choose to do substitution this time. So I'm going to take my equation here, x plus y equals 30, and I'm going to solve for x. So I'm going to subtract I'm going to subtract y from both sides. So minus y. So x is equal to 30 minus y. Now that I got the x alone, I can take 30 minus y and substitute that back in for x. So now my equation is going to be 0.10 times 30 minus y plus our 0.05y equals our $2.60. We're going to distribute the 0.10 inside the parentheses to get 3 minus 0.10y plus 0.05y equals $2.60. We can combine our like terms to get 3 minus 0.05y equals $2.60. And then we'll subtract both sides by 3 to get negative 0.05y equals negative 0.4, and divide both sides by negative 0.05, and we should get that y is equal to 8. So we know that there are 8 nickels. Now we can actually stop there because the question says how many nickels are there. So we can say that there are 8 nickels. If you wanted to continue to solve and go back to solve for x, we could plug 8 back into this top equation. So we could say x plus 8 equals 30, and then we could solve for x to get x equals 22. So there's going to be 22 dimes and 8 nickels. But again, we're only looking for the nickel answer. So there are 8 nickels.